In this video, we want to look at sets. And in particular, we want to look at when we have two sets. How do we draw a Venn diagram? Of course, the two sets must be a subset of the universal set. So we have three possibilities. Here we have set A and set B. Set A has no elements in common with set B, and those will be disjoint sets. All right, so we're going to write set A and set B has no elements in common. And we can see that the circles are apart, and that's what we call disjoint sets. Okay, now for our second diagram here, our second possibility, we have where set A and set B would have some elements in common, and we call those intersecting sets. All right, so here we have set A and set B have some elements in common. All right, and this little space here will represent the elements that they have in common. So I'm just going to shade that. So this here that I've shaded in green would be the intersection of the two sets. And we could write A intersect B. So that's what the symbol means. Intersect is not an N, so don't confuse it with an N. And this would mean A has some elements in common with B. So this is the intersection. Now, our third possibility is if all the elements of one set is contained in another set. And that's what we call a subset. So the way I have this set up here, you can see B is inside of A, which means all the elements of B is contained in the set A. Therefore, B would be a subset of A. So here we have all the elements of B. I should put set B is contained in set A. Therefore, B is a subset of A. Now, I just loosely use the word subset. Now, what we call this is a proper subset. Proper subset means that, the elements in B is actually contained in A, meaning B has less elements than A. And how we write that as a symbol would be B is a subset of A. Now, if A and B had exactly the same elements, now let me write that down. So, if set A and set B had exactly the same elements, then we will write the same subset, but we'll put B, put the subset symbol, but we put this line below it, A. So this still means B is a subset of A, but if they have the same elements, they essentially equal to each other, okay? And this is the symbol that we use for a subset. Same subset symbol, but with a dash below it. So now the purpose of this video is how to draw the Venn diagrams when we have two sets. Of course, they must be a subset of some universal set. And, our possibilities being disjoint, intersecting, or subset. So now let's look at that. So here we have for our first question, we have our universal set containing numbers from 1 to 7. We have set A, which you can see is the odd numbers, 1, 3, 5, 7. And we have set B, which are even numbers, 2, 4, 6. Now clearly set B and set A have no elements in common. And therefore, because they have no elements in common, we're going to draw the circles apart from each other. So these are disjoint sets. So here I have my Venn diagram. I have my rectangle for my universal set. We have set A and set B, which is contained inside the rectangle. So set A and set B are subsets of the universal set. And for set A, we're going to put these elements here, 1, 3, 5, 7. So that's 1, 3, 5, 7. And for set B, we're going to put the 2, 4, 6. So 2, 4, 6. So now we need to look and see if we have any elements outside the sets A and B. that will be contained in the universal set, but not in A and B. So let's check. So we have 1 here, we have 2 here, we have 3, we have 4, 5, 6, and 7. So all the elements in the universal set is contained in either the sets A or B. So we have nothing outside the 2 circles. So here we have question 2, where we have our universal set goes from 1 to 10. We have set A here, which is 2, 3, 5, 7. If you recognize these numbers will be prime numbers. Then set B would have the elements 2, 4, 6, 8, 10, and these will be even numbers. Now before you start drawing your Venn diagrams, you have to know how to put these circles, either they are disjoint, intersecting, or a subset. So we look to see if we have any elements in common here. Now remember, if we have no elements in common, it's a disjoint set like this. If we have some, the circles are intersecting. And if you have all the elements of one set containing another, that's a subset. So here I'm just going to look through and see if we have any elements in common. So here we have 2, and 2 here is common to both sets. I can't find anything else. So we only have 1 element in common. Now 1 or some, that will be intersecting circles. Now the reason I'm emphasizing some, although we just have 1 element here, because remember it's subset. If all the elements of one set is contained in another, that will be a subset. But the intersecting is if you have some or 1, right? Here I've drawn the rectangle and the circles for my Venn diagram. I have my universal set here, the rectangle. And I've drawn set A and set B intersecting each other because we have this element here, this 2 in common to both sets. And therefore that 2 will come here in the intersection. So we're going to have 2 here. So then we go through the other elements. We have 3, 5, and 7 remaining in A. So I'm going to put the 3, 5, and 7. Then when we look at set B, excluding the 2, because we already put the 2 in the intersection here, we look at the other elements, which is the 4, 6, 8, and 10. And we put that here, 4, 6, 8, and 10. Now we're going to look to see if we have any elements outside here, which will mean any elements that's not contained in A and B, but is contained in the universal set. So I'm going to start crossing out. So we have 2, so we cross out 2 here. We have 3, 4, 5, 6, 7, 8. We don't have a 9, so I'll leave that there, and we have 10. So what we could see from here is that 9 remains and 1 remains. So 1 and 9 will be outside here. So we have 1 and 9 outside the 2 circles A and B. And now that we have completed our Venn diagram, I'd just like to point some things out about this intersecting diagram, or these intersecting circles. Now A intersect B is 2. So A intersect B would only contain 1 element, which is 2. And now here, we're going to call this A only. So this 3, 5, and 7 will be A only. Now the whole set A had 2, 3, 5, 7. So that's the 2, 3, 5, 7. But A only means without the intersection, we have 3, 5, and 7. So I'm going to write A only is going to have 3, 5, and 7. Likewise, B only going to have the elements 4, 6, 8, and 10. Now the whole circle B has 2, 4, 6, 8, and 10, which is the whole set B, 2, 4, 6, 8, and 10. But B only doesn't contain the intersection, so it's just the 4, 6, 8, and 10. So that's 4, 6, 8, and 10. So now let's move on to our third scenario where we have a subset. So here we have question 3, where we have our universal set contains elements from 1 to 7. We have our set A contain elements 2, 3, 4, 5, no 6, but 7. And we have the set B 3, 4, and 5. Now, the first thing before you start drawing a Venn diagram is to look to see if the sets have any elements in common. Remember, if they have no elements in common, disjoint. Some is intersecting, and all will be subsets. So I'm going to circle. I have 3 here and 3 here. So I have elements in common. I have 4, 4, 5, 5. So now that I've circled the elements in common, we can see that all the elements in B is contained in A. Therefore, B is a subset of A. So the circle B is going to be drawn inside of the circle A. So here I've set up my Venn diagram, well, that is the rectangle and the circles. So I have my universal set U, which is the rectangle, set A and set B. Of course, B is drawn inside of A because B is a subset of A. Now, the first thing you should do when you're drawing a Venn diagram is put in the elements that are in common. So we have the 3, 4, and 5. Those are the elements that are in common to both sets. Now, where would I put the 3, 4, and 5? Well, the 3, 4, and 5 are contained in B, and we have drawn B inside of A. So I'll put the 3, 4, and 5 here, which means the 3, 4, and 5 is inside of B, and it's also inside of A. So now that the 3, 4, and 5 have been put in, the remaining elements in A is just 2 and 7. So we'll put that outside here. 2 and 7. Now we'll check to see if we have to put any elements outside here. So we have 2, we have the 3, we have the 4, we have the 5, we have the 7. Now I didn't cancel anything here because the 3, 4, and 5, 3, 4, 5, same thing up here, right? Now we can see that 1 and 6 remains. So we put the 1 and 6 outside here. And of course, because B has less elements than A, it's a proper subset. So B is a subset of A. And that will be it for this video.